Hello everyone. Today I'm going to start my session again. So first, what we did still now in power series, starting with the classify the points in that you have found ordinary and singular points. Then second, another method it was ordinary points that we already did in classroom, and the third one is singular points that I think we didn't started. Okay. So mainly there are three methods in power series. First one that is classify the points that is coming in 3 to 4 marks in GTU examinations. Ordinary points that is coming in 7 marks as well as singular points also coming in 7 marks. Okay. So please be careful and please do properly. Okay. Ordinary points that already we did in classroom. So again I am not repeating. So I'm starting with the next method that is singular points. So singular points that is also known as by Frobenius method. Please keep it in your mind. So there are three cases for the Frobenius method. First one case is we are going to start. See the method of Frobenius. Here I have written theory one by one steps that which steps what you are going to do. So please read this carefully. I'm directly applying in the examples. There are total 6 steps, and then after you have to decide the cases in which cases it will be applied. It will be applicable. Okay. So for that 1 to 6 steps, these all 6 steps are common. Okay. So starting with the first case in which when the roots m1 and m2 are distinct and differ by a non-integer. Here you have to find two roots and roots depend actual on the equations. If in the equations the hash derivative is given by double dash second derivative, then you can find two roots. If it is given a single derivative hash, then you can find it's a single root only. Okay, so 99% second derivative will be your hash derivative. Okay, so in all the examples you will find two roots only, that m1 and m2. Okay, so if these both roots are distinct and it is differ by a non-integer, then its general solution is given by y equals to a into y1 of x plus b into y2 of x, where a and b these both are arbitrary constants, and y1 and y2 that we are going to find, where y1 of x equals to summation k equals to 0 to infinite ck access to m1 plus k, in which m is constant. So keeping aside x is to m1, summation k equals to 0 to infinite ck access to k. And now again do the expansion of this series ck access to k, and that you know very well now, right? And the second one y2 of x, that will be again summation k equals to 0 to infinite ck access to m2 plus k. Again m2 will be the constant, so keeping aside access to m2, summation k equals to 0 to infinite ck access to m. Okay, so please remember this formula, y equals to a into y1 and b into the y2. Also y1 and y2, these both are the important terms that you are going to find here. Okay, so starting with the first example, see the question. The question is solve in series, or it will be like find the series solution by using Frobenius method of the equation 3xy double dash plus 2y dash plus y equals to 0. Okay. Okay. Uh, in the starting, you have to do that classify methods. It means you have to say whether it is of ordinary or it is from singular points. Okay. So for that you have to do that method again, that is of classify. It means you have to find ordinary or singular points. Okay, so for that you have to make a form of y double dash plus p of x into y dash plus p of x into y equals to 0. Then after you have to find p of x and q of x, and in place of p of x and q of x, it means its denominator. In the denominator you have to put x equals to 0. Whether it is being 0, then it will be singular. If it is not being 0, then it will be ordinary points. So here it is being 0 denominator, so it will be of singular points. Okay, here I have not written that method, but you have to write. It's compulsory to write. Okay, so don't forget. So singular points, now it's final, and for the solution is y equals to summation k equals to 0 to infinite sec k x is to n plus k, as we did in our last session. Okay, now see the question. Here it is given variables. See the variables y, y dash and y double dash. Okay, so we having y. Now you have to find y dash and y double dash. So first find y dash and y double dash. What will be y dash? It means the first derivative. So it will be summation k equals to 0 to infinite sec k. M plus k will be go ahead. So x m plus k x is to m plus k minus 1. Again doing one more derivative. So it will be y double dash. That will be a summation k equals to 0 to infinite sec k m plus k minus 1 into the x is to m plus k minus 2. It means you have to do two derivatives, y for the y dash and for the y double dash. Okay. Now see that all 6 steps. First steps, you have to put all the values in the given equations, which is given into the equations. Okay. So 3x will be as it is. In place of y double dash, you have to put its value that we have found right now. Okay. Plus 2 as it is, again y dash, again put the value, and plus y, again put its solution. It will be 0. Okay. In the second step, if in the multiplication of y double dash it is given any brackets like 1 plus x square, or into the bracket x square plus 2, or into the bracket x cube plus 4, etc. Okay, then you have to first open the brackets. But see here it is not given any brackets. Okay, so directly we are applying. So directly we will convert into the single term of x. Okay, it means, see here, there is two terms of x, so converting into the single term. So 3 as it is. Here x having single power, so summation k equals to 0 to infinite m plus k minus 1 as it is, sec k as it is. So here it will be m plus k minus 1. Okay, plus 2 as it is. See the here, there is only a single term of x, so no need to simplify, so keep it as it is. As well as third one, there is no x, so again keeping as it is. Okay, now next one, yeah. Okay, so next one step. Now see if any term having a similar power or not. Okay, so there are first two terms that having a single power, similar power, and that is m plus k minus 1. So take out the common if anyone is similar terms. So summation k equals to 0. In both terms, this both term having m plus k is common term. So keeping common m plus k, and the rest of the remaining term I am writing here, that 3m plus 3k minus 1 ck as it is, x is to m plus k minus 1 as it is, and the last term again keeping as it is. Okay, this one is important simplification, don't forget, because from the first term m plus k is common but 3 is not common. Okay, so multiplying 3 into the bracket, so it will be 3m plus 3k, and from the another term it will be minus 1. Okay, now see the terms, this both x having not similar power, right? In first term it is given m plus k minus 1, and another one it is given m plus k. but you have to make a common term. It means you have to make a similar power. Okay, see the first power, that is m plus k minus 1. So same in the last term you have to also make same power m plus k minus 1 only. It means we are going to change in k. Okay, so in place of k I am putting k equals to 1. So make its factor, that will be k minus 1. Okay, so in place of k I am putting k equals to 1. It means its factor will be k minus 1. Okay, so see the next step. In place of k equals to 0, I am writing k minus 1 equals to 0. So it will be k equals to 1. Where k, see k, it means it will be ck minus 1, as well as here access to m plus k. So it will be here access to m plus k minus 1. It means we are putting in place of k, k minus 1. Okay. Now see both the terms, these both term having a similar power, that is m plus k minus 1. But see the limits. In first one it is starting from 0 to infinite. In the second one it is starting from k equals to 1 to infinite. We made a similar terms, similar power, but see its limits. Now its limits are not same. Okay. For that, but see which one is its common limits. In first term it is starting from 0 to infinite, right? And the another one is starting from 1 to infinite. So which one is common? That is from 1 to infinite. So keeping aside k equals to 0, so first putting k equals to 0 in this first term, so it will be term m into m 3m minus 1 c0 into x raised to m minus 1. And that is how, by putting k equals to 0. Now these both terms are similar and it is starting from k equals to 1. So the final term will be k equals to 1 to infinite into the bracket m plus k 3m plus k minus 1 whole bracket into the ck plus ck minus 1 bracket over into the x raised to k m plus k minus 1 equals to 0. Okay. Now, as you know, you have to equate the coefficients, you have to equate the terms, right? So the first term equals to 0 as well as the second term equals to 0, and if you having third term, then again put third term equals to also 0. Okay, but see here we having only two terms. So keeping first term equals to 0, so it will be m into 3m minus 1 into c0 equals to 0. We are equating the terms of x. It means don't write x over there. Don't forget. Okay. Now m into 3m minus 1 into c0 equals to 0. But we can't write c0 equals to 0. Why? Because that actually we are going to find here. Okay. So c0 never will be 0. It means ultimately we can find the roots, and that is m. So m equals to 0 as well as 3m minus 1 equals to 0. So make a subject of m. So the final root will be m equals to 0 and 1 by 3. Okay. So till this, your all three cases are same procedure. These three cases having a same procedure. Okay. Then after we will decide it is converting into the first case or second case or the third case. Okay. Now see the first case, the roots will be a different and it will be differ by a non-integer. What is the meaning of non-integer? Non-integer यानी कि at least one of the root will be a fraction form. Okay. So see here it is given, here we are getting 1 by 3. So it is a non-integer. So 0 and 1 by 3. Okay. Now moving for the next step. Again second term equals to 0. So it will be m plus k into the another bracket 3m plus ck minus 1 into the ck plus ck minus 1 equals to 0. Right? Okay. So in the next term you have to make a subject of ck, that actually we are going to find. Okay. Ultimately what we are going to find, we have to find its series solution. And what is its series? That c0 plus c1x plus c2x square up to the so on. It means you have to find constants. Okay. So here you have to make a subject of sec. So what will be that minus into sec minus 1 upon m plus k into 3m plus sec k minus 1. Okay. So then after we'll start in our next session. Bye bye guys.